Hello and welcome to this video. Today I'm going to be dealing with an aspect of coordinate geometry which you call gradient. So I'm going to be dealing with gradient. Okay, we have many different aspects of inside in coordinate geometry. We have distance between 2 points. We also have equation of a straight line. We also have midpoint and so on and so forth. But today I'm just going to be talking about gradients. So gradients, the first thing we have to take note of is, or the first thing we have to talk about is the definition of this mathematical term, which is called gradient. So in gradients is simply defined as the ratio of the change in the function's output to the change in its input. If you can watch what I put here, I put something here called vertical axis and this side called horizontal axis. That means gradient is just the change, or the ratio of the change in the vertical axis and horizontal axis. When you say vertical axis, we are talking about a graph, okay, where you have this part to be x as y axis and this part to be x axis, okay, and their point of intersection is point 0, and this part is maybe 1, 2, 3. So this part 2, 1, 2, 3. All this part will be positive. All this part here will be positive. All this part will be positive for x. Y this will be positive for y. And this part is going to be negative for x. And this part will be negative for y. Okay, we are dealing with graphs. When we talk about x-axis, horizontal axis and vertical axis. So we're dealing with graphs. Okay. So I'm going to get rid of that right now. Yeah, let's move on. So I'm going to be moving on, okay? Because remember, gradient is the ratio of the change in a function's output, which is the ratio of the change on the vertical axis to the change in the horizontal axis. That's the ratio between the two of them. You find the change in the vertical axis and you find the change in the horizontal axis, and then you divide your result. That's the definition for gradient. So, and I said it's just like a graphical representation. So if you had to show this thing, first we'll have to start with an example. So the example is this. On the example, you can see x and y labeled there. So this part is the x, and the other part there, this is the x, and this is the y. Okay, so that's our x and that's our y. So where does this 6 and 8 come in? This is an example, so it's an assumption that if this here is 6 for x, then the corresponding point of that 6 is 8. Okay, the point of that 6, the point on the x that corresponds to the y is 8. So why the x is 6, then the y is 8. That's what it means. So the same thing here. When x is 2, then the corresponding side for 2 on the y-axis is 4. Okay, so that's what I'm going to use for this. So since I said it's going to be a graph, so I'm going to be going straight to the graph. I'm not going to bring a graph into this video. I'm just going to sketch. Okay, I'll just sketch everything out. So it's as an assumption, just for you to understand what we mean about gradients. So first, I'm going to draw straight lines, okay? The first straight line, as you can see here, this comes first. Either your vertical comes first or your horizontal comes first, whichever way you want to draw it. So this is my y-axis and this is my x-axis. Those are the lines, okay? Now I'm going to label them accordingly. So I'll label them accordingly. as the y-axis right there. I didn't put axis, but it's y-axis. So, on the horizontal line is what you call the x-axis. The vertical line is the y-axis, and the horizontal line is the x-axis. That is what is generally accepted, y-axis and x-axis. Although we have z-axis, that's when you're dealing with 3 dimension, but this is 2 dimension, so it is y and x-axis. So now the next thing is for you to write all the lines, all the points on the y-axis. You might use 1, 2, 3, 4, 5, 6. You might use 2, 4, 5, 6. You might use 4, 6, 8, depending on the points that you have on the y, on the y, depending on the points you have on the y. So any one you want to use, you can use 1, 2, 3. What I mean is what's going to be on this place, what's going to be on this place, what's going to be here, what's going to be here, what's going to be here. So I need to just put my points on that y. So I'm going to do that now. So on the y-axis, these are my points, 2, 4, 6, 8. I'm using 2, 4, 6, 8. Okay, I could decide not to use 2, 4, 6, 8. I could use 1, 2, 3, 4, 5, 6, and so on and so forth. But 2, 4, 6, 8 is much more okay, because if I use 1, 2, 3, 4, 5, 6, 7, 8, it is going to be too large. I mean, too large, there won't be enough space on my 1, 2, 3, on my y-axis rather. So on my x-axis, I'm also going to be using 2, 4, 6, 8. This is what we call, you are using 2 units, okay? I mean, 2 centimeters represent 2 units on the y-axis, and 2 centimeters represent 2 units on the x-axis. But that's not what we want to talk about today, so I'm going to move on. So now I'm going to move on by connecting the points, because I said before that if this is 6 on the x-axis, what's the corresponding point to 6 on the y-axis? So that's what I'm going to now pinpoint out of my graph. So I'm going to pinpoint that out of my graph. Okay, so to do that, I will have to trace 6 on my, I'll have to trace 6 on my, okay, let me start with 2. Let me start with, 6 on my x-axis, okay? So I'm going to trace 6 on my x-axis first. So I'll start with 6 on the x-axis. So if I trace 6 on the x-axis, I'm going to draw a straight line. And before I go to that, I want you to also take note that this part is our 0. That's the intersection point between y and x, okay? So now, moving on. So I've traced that 6 with dotted line or dash or broken lines, whichever one you want to call it or whichever one you want to use. Now I'm going to trace 6 and I'm going to trace 8 on my y-axis. So you can see I have 6 here on my x-axis. When I trace that my 6, I could draw this line all the way up, but what I'm looking for on my y-axis is 8. So now this is my 8, so I'll just have to just stop at this junction. I'll use my eraser to clean this off and then stop everything at this junction. So that's where 8 and 6 meet each other. So what we are doing here in essence is we are finding the point of intersection between the axes, okay, or between the points on the axis. So we are finding the point of intersection. So the point of intersection between 8 and 6 is this place. This is where they intersect each other. All right? So I'm going to go to the next point. Now going to the next point. The next point here is 2 and 4. So I need to intersect 2 and 4 also. So if I want to intersect 2 and 4, then what I'm going to do is I'm going to go to my x-axis or pick 2, draw a straight line as long as possible. But this is an educational video, so I'm going to just have to go straight to the point. So this is 2, and I'm tracing it up to 4. 4 is on my y-axis, so I'm tracing up to 4. So I've traced the point already. Now if you look at this point, it's going to form something that looks like a triangle. You can watch this straight line go here, or the other line straight down, and then you have something called a triangle, which is also a right angle triangle. Whenever you have a symbol that looks here, this symbol here is called 90 degree. So this is a right angle triangle. So that's what it forms. But in this aspect, we are not going to be using this triangle, although it is very useful, but we're not going to be using its ingredients. Where we're going to be using it is when we're finding distance and midpoint. That is where we're going to be applying this triangle. We're going to be using it to be solving. Okay? So, but in this case, we don't need it for gradients. What gradient is all about, I'll show you in a moment. Hold on. So yeah, I said I was going to show you what gradients mean. Now, when you say gradient, because this is also already forming a triangle. On that triangle, it's like you have, let's say you have, for instance, let's say you have a ball. Say you have a ball on this platform here. When I mean platform, I mean a ball trying to slide all the way up that flat platform. Maybe the ball is trying to slide up. Okay, you are trying to push the ball up that platform. The ball is going to do a lot of work. Okay, but the work that the ball is going to be doing is that the ball is going to be doing work against this vertical plane. Okay, and it's going to be working also against this horizontal plane. That's one of the functions of gradients. So for you to find the amount of work it's going to be doing, okay, to just be the change in this vertical plane to the change in this horizontal plane. So when I say vertical plane, maybe like distance to, let's say like vertical height rather, and then when you say vertical plane, I mean height, then horizontal plane, I mean just distance. So what is the amount of effort you are going to apply for you to overcome this, the force that is sliding down, okay? The sliding down force on this this plane, okay, this inclined plane, all right? It's like doing machine and physics. So what's the amount of work that is going to be done? So you have your H divided by your L. That's H over L. So that's what it means in general. But that's not what we're going to work on in this aspect. This is mathematics, so I'm going to show you. So I'm going to show you how to do it. Now, since we've picked the point, so it means on this point right here, that's 6, 8. That is where we picked our 6 and 8. And this place is where we picked our 2 and 4. And then we can name the point just to give it more meaning. So we can name this side A, or we can name this point B. What I'm talking about is this point right here. This point of intersection, okay, it was caused by 6 and 8, while this point of intersection was caused by 2 and 4. Okay, so that was 6 on the x-axis and 8 on the y-axis, while this one was 2 on the x-axis and 4 on the y-axis. Right, okay. So now that we've dealt with that, so I'm going to move on to that definition of gradients. So the definition of gradients, we're going to write it out in terms. So gradients, as its definition, it is the change in the vertical axis divided by the change in horizontal axis. So if I had to write that mathematically by using mathematical letters, or any letter, or mathematical terms. So gradient is just written mathematically as y2 minus y1 over s2 minus s1. That is the change in your y-axis, that's your vertical axis, over change in your x-axis, which is your horizontal axis. So by how much has there been a change in your vertical axis? You can see this is the vertical axis, and this is where the point is lying. Okay, right? This is the vertical. So this is the point here. So on this vertical, we have 8 and 4. So by how much has this 4 changes to increase up to 8? That's why we have to minus 8. We have to do 8 minus 4. Okay, that's why we have to do 8 minus 4. So we want to know what is between these two guys. It is not that 6 is what's going to be in between them. No. 6 is just the point that is here. But by how much has 4 increased to get to 8? That's what we're doing, y2 minus y1. And y2 is the highest point on your y-axis, and y1 is the lowest point on your x-axis. I know that the lowest point on the y-axis is this 2, but this is the point we're dealing with, 4 and 8. So 4 is going to be our lowest point, and 8 is going to be our highest point. So that's why 8 is going to be y, and 8 is going to be y2, and then 4 is going to be y1. So the same thing will apply to the x-axis too. Okay, it will apply to the x-axis also. These are the points on the x-axis. These two guys, 2 and 8. So by how much has 2 increased to get to 6? So that's 6 minus 2. Okay. So I'm going to quickly go on to put in the values. So therefore, if we have identified our y2, y1, s2, x2, x1, so we can go ahead and write our gradient as 8 minus 4 divided by 6 minus 2. And you can see that I put BA right here. Okay, meaning the gradient BA is what? So what's the gradient BA? That is, we have labeled the point as B and A. So what's gradient BA? Or you can say gradient AB. Whichever the case, okay, it's still the same thing. So that is going to be resulting into 8 minus 4, okay, divided by 6 minus 2. So if we add 2, write that is 8 minus 4 is 4, and 6 minus 2 is 4. So we have 4 divided by 4, which is equals to 1. So in this aspect, our gradient is just 1. So guys, this is just the introduction to gradients. This is how gradient actually is. Okay, but in most mathematical questions, nobody is going to ask you to work your gradients in this graphical format, except maybe in physics. But in mathematics, we don't really have that, except maybe in quadratic graphs, where you have to find the gradient of a curve, but not really in this. This is just an introduction. So now I'm going to move into the mathematical question that comes around in gradient. So for example, I'm going to start with this. Now it says find the gradient of the line described by the point. This is the point A. Point A has its coordinates. Those things are called coordinate. That's 6, 8. That is the point of A. Okay. So coordinate A is 6, 8, and coordinate B is 2, 4. So find the gradient described by those points. Okay, so to find the gradient described by both those points, we're not going to be writing gradient is equal to vertical axis over horizontal. We're just going straight to the solution. So the solution is just going to be gradient, which is equal to y2 minus y1 divided by s2 minus s1. But first, I had to draw graph for me to be able to identify. I have to draw graph here for me to be able to identify my y2, y1, s2, my y1, and s2. But what if you don't have to draw a graph? How do you identify your y2, y1, and s2, s1? It's very easy. Okay, it's very easy and very simple. Just follow me. So just follow me and you'll get it quite simple. So if I ask you that simple question and I ask you to find the gradient, first you write the gradient expression. That's the mathematical expression for gradients. That is y2 minus y1 over s2 minus x1. So once you're done with that, now you will write that coordinates. You write the coordinate back, the coordinate given to you in the question, which is 6, comma 8, and the other part is 2, comma 4. Okay, 6, comma 8 and 2, comma 4. So I want to use that to identify my S2, my Y2, my Y1, my X1. So what I'm going to do is I'm going to compare this thing with the coordinate points. The way the coordinate points is always written. It's always written in this fashion, which you call x1, comma y1. Then the other point is going to be carrying 2, 2. So please don't mix it up. This is x1. There's a comma in between them to separate the 2 points. So they are separated. This one here is the other point. So we, instead of calling it x1 again, it will be x2 this time around. And this one will be y2 because we've mentioned x1 and then we've mentioned y1. So the other part is going to be s2 and y2. So you're now going to be relating the points to that x1, y1, s2, y2. So I'm going to be doing that in a moment. Now I'm going to relate the point. The first point, which is 6, is looking just the way x1 is. The place x1 is positioned. So that's why I have to put the arrow there. So 6 is representing x1. And 8 is representing y1. Now if you go to the other point, okay, 2 is going to be representing x2. And 4 is going to be representing y2. That's how you pinpoint your y2, y1, s2, y2 easily without any issues. Okay, so once you have pinpointed them out, you have your x1 now. Your s1 will be equals to 6. Your y1 will be equals to 8. Your s2 will be equals to 2. And your y2 will be equals to 4. So you can now find your gradients easily since you have your y2, s2, y1, s1. Okay, so therefore gradient AB, since we have point AB, so gradient AB is going to be 4, which is our y2, minus 8, which is our y1, divided by 2, which is our x2, minus 6, which is our x1. Alright, so gradient will be equals to minus 4 divided by minus 4, because 4 minus 8 is not just 4, it is negative 4, which is minus 4. 2 minus 6, because you can't remove 6 from 2, okay? You'll be tracking back to negative side, so that's why it's negative 4. So that's minus 4. So minus 4 divided by minus 4 is going to result into 1, because the negative are going to cancel each other out. So our final result is just 1. Okay, I hope you understand this. If you don't understand it, you can go back a little bit. Okay, just pause the video and take it back. Try to watch it properly, and then you get it. It's very easy. So now on this next part, I'm going to go directly to the questions. Okay, now another question can come this way, just the same as the first one. You could be asked to find the gradient between 2 points. So if it's you can't be asked to find the gradient between in 1 point. No, you can only be asked to find the gradient described by 2 points rather. Okay, or gradient of a line passing through 2 points. So now to find the gradient of another point, here you should find the gradient of the line described by the point. So this is point Q and point P and point Q. So the same way we did the previous one, we're going to go straight to the solution. We have to find our x1, y1, s2, y2. Okay, it's not difficult. You just have to first write that expression, which is a gradient, and then you move on. You pinpoint your s1, y1, and the like. So to pinpoint that, you write the points out. You don't need to put P and Q. It's not necessary. So just compare that point to this x1, y1, s2, y2. So if I compare that, that means my 5 is going to be x1, and 3 is going to be y1, and then 7 is going to be s2, and then 10 is going to be y2. So I can go ahead and find the gradient. So gradient will just be equals to 10 minus 3 divided by 7 minus 5, which is gradient PQ rather. So which is 10 minus 3 is 7. 7 minus 5 is 2. So I'm going to have 7 over 2, which is equals to 3.5. Okay, that's all about it, and it's very simple to find gradient of a line described by 2 points. So this is another question which is just about the same thing. You can solve this yourself. You can pause the video, pause it, try to solve it yourself. If you don't get the expression you're going to use, you're going to find your S1, your Y1, check the question at the top there, and you can go back to the previous one, okay, and then I'll come back and solve this. So once you're done, you play the video back. So I'm going to pause for a little while. All right, so I believe you've solved it, and this is the solution. The solution to it is gradient is this. If gradient is that, then I have to identify the points. So identify x1 to be 16, y1 to be 2, 24, s2 and 9, y2. So I can go ahead to find the gradient. So gradient is st, that's point st, is equals to 9 minus 2 divided by 24 minus 16. That's 7 over 8. 7 divided by 8, which is equals to 0.75. Okay, that's the result, and that's all about gradients for now. Okay, the introduction to gradients rather. So thank you for watching. Have a nice day.